Good evening. I take this opportunity to welcome you to our class. Before we commence on our lesson, I want to thank you so dear for your support. So today we are looking at linear inequalities. Our objective is to obtain linear inequalities from a given graph. So we are going to apply an example, as well as say, use of an example. So we can think of an example very fast and say, obtain the linear inequalities that satisfy the region shown below. So we can have the region So let this be our y-axis. Let this one be x-axis. So we can let this one to represent 1, 2, 3, 4. 1, 2, 3, 4. 0, minus 1, minus 2, minus 3. Minus 3, minus 2, minus 1. Then we can now create the region. So we can now identify the region and say that is the region we are talking about. So we can break our lines. This is first line L1. This is L2. This will be L3. So how do we obtain linear inequalities from the region and the? So we must identify two coordinates through which each line passes. I can comfortably say that this given point here, we have the coordinates of 1, 0. This given point here is 0, 2, 0, 2. So it means line 3 is passing through 0, 2 and 1, 0. Line 1 is passing through this given point, which is 3, 0. Being a straight line, being a line that is parallel to y-axis, we can easily state its equation. So we don't have a problem with M1. So let's identify 2 points through which L2 passes. One given point that is here is this given point here, which is minus 1, 0. And this given point here, we can approximate and say this given point is 0, 1. This point here, you can say 0, 1. Now that we have identified 2 points for each line, we will start by finding the gradient of each line. After obtaining the gradient of each line, we will now obtain the equation for each given line. After obtaining the equations of the lines, which are line 1, 2, and 3, we will identify one given point on the wanted region R. So in this case, we can identify even now. So the region, inside the region R, the point that we can see here is 2, 2, which is likely to be at that given point. So we will use this 2, 2 as our reference point, so as to obtain the linear inequality symbols. So once we do all of that, we will start by finding the gradient of each given line. We obtain the equation of each given line, and then coming up with linear inequality symbols, we will use this point, which I have identified as our reference point. So let's start from line 1. So we will say for line L1. For line L1, this is a line that is parallel to y-axis. Once the line is parallel to y-axis, we will just look at where the line is cutting x-axis. So for instance, this line is cutting x-axis at 3. Therefore, our equation for that line will be so simple by saying x is equals to 3. Because the line is passing through x-axis at 3 and it is parallel to y-axis. If we were to be given a line that is parallel to x-axis, we will just look at where the line is passing through y-axis, and then we say y is equal to that given number. So lines that are parallel to either y-axis or x-axis are very simple to find their equations. So once we obtain the equation of that given line 1, we are supposed to prove whether we are going to have greater than, less than, greater than or equal to, less than or equal to. How do we do that? We will use our reference point. So in this given equation, our power of x will be 2. From this given point, first 2 represents x coordinate, the other 2 will represent y coordinate. And in this particular equation, we don't have y, we only have x. So if we put 2, which is now power of x here, we will have 2 is equals to 3. Then we will ask ourselves, which statement will fit what we have obtained here? Can we say 2 is greater than 3? We cannot say that 2 is greater than 3. Can we say that 2 is less than 3? Yeah, we can do it. So we will say 2 is less than 3. That statement is very true. So we will again decide whether to include equal to or not, depending on the line. If the line is continuous, then now you introduce equal to. Now this statement is very true. So once you obtain the symbol, you now come and say x is less than or equal to 3. So that's the linear inequality for this line. So let's go to line 2. So we will say for line L2. Since L2 it is neither parallel to any of these axes, then now we will identify the 2 points. Line 2 is passing through 0, 1, 0, 1, and it is also passing at minus 1, 0. Minus 1, 0. We know that if we are given these 2 given points, we can obtain the gradient. Now we will apply the concept of gradient and the equation of a straight line. This point becomes x1, y1, x2, y2. So how do we get the gradient? We know the gradient is change in y over change in x, which is the same as y2 minus y1 over x2 minus x1. So our gradient will be 0 minus 1 over 0 minus 1, then minus 1 minus 0. So this will give us minus 1 over minus 1. Minus 1 divided by minus 1, it becomes positive 1. So the gradient of line F2 is 1. We want to obtain the equation. Once we have the gradient, we can choose one of the points that we have, and then we assume we don't have the other given point. So once we have done this, we now apply the same concept of finding the gradient by saying y minus 1 over x minus 0 should give us the gradient. So if we put 1 over 1 is the same as 1, it doesn't make any difference. Then we cross multiply that. So we will have 1 into y minus 1 is equals to 1 into x minus 0. Therefore, this is y minus 1 is equals to x, because 1 times 0 is 0. Therefore, we take this one to the other side. Y is equals to x plus 1. That is the equation. So for us to be able to come up with the symbol, the required symbol, we will use our reference point, which is 2, 2. 2, 2 means the power of y is 2, the power of x is 2, then we add 1. 2 is equals to 3. So which symbol can be true if we put it there instead of the equal sign? We can comfortably say that 2 is less than 3. So do we include equal to or we cannot? So it depends on the line. If the line is continuous, we will. And if it is not continuous, we will just leave it at that given point. Now because it is continuous, we bring in equal to. Now this is what we place here and say y is less than or equal to x plus 1. Let's look at the last line, which is for line 3. For line L3. We will identify the points through which the line is passing. How we did that? The first one is 0, 2. That's the first of the, that's our first point. Another given point is 1, 0. 1, 0. Then we find the gradient. That's the first step, which we know change in y over change in x is what gives us the gradient, which means y2 minus y1 over x2 minus x1. So we will write from this given first point is where we obtain x1, y1. The other second point is will give us x2, y2. So our gradient now becomes y2, which is 0, minus y1, which is 2, over x2 is 1, minus x1 is 0. This gives us minus 2 over 1, which finally gives us minus 2. So that's our gradient. So once we obtain the gradient, we now go back to finding the equation. We have found the gradient. We pick one of the points. You can pick the first given point. We assume that we don't have the other point, so we put xy. So using the same method of finding the gradient, we will take change in y. That's y minus 2 over x minus 0 is equal to the gradient. So we can put over 1. Then we cross multiply. So allow me come back here. So from there we will have 1 into 1 times y minus 2. Y minus 2 is equals to minus 2 times x minus 0. Minus 2 x minus 0. Opening the brackets, we will have y minus 2 is equals to minus 2x then plus 0. Therefore, this is y is equals to minus 2x. We take this minus 2 to the other side, it will become a positive. So that's our equation. But we should come up with the linear the linear inequality symbol for this particular line. So we will use this equivalent, which is 2, 2. So we will come here and say our y is 2, because from here you are able to see y is 2, is equals to minus 2 into x is also 2, then plus 2. So 2 is equals to minus 4, then plus 2. Minus 4 plus 2 is equals to minus 2. So we will now ask ourselves, is 2 less than minus 2 or greater than minus 2? So all of us, we know that on an upper line, minus 2 comes first. So it means it is smaller. So we will now say 2 is greater than minus 2. So let's look at the line. Is the line continuous? No, it is not. If it is not, we don't include the equal to sign. So we leave it at that given point. We now come back to our equation. We say y is greater than minus 2x plus 2. So this is our linear inequality line. So that's how we do it. Thank you for listening to this particular lesson. Bye. See you next time.